Hello, this is Kelly Morimoto. Welcome to my pencast for Physics 6B for spring quarter. So the problem that we're working through today is problem number 37 on homework 1. So the situation is an opera singer in a convertible sings a note at 600 hertz while cruising down the highway at 90 kilometers an hour. What is the frequency heard by A, a person standing beside the road in front of the car, so that's person A here, or B, a person on the ground behind the car, so that's this person right here. So the things that we know is f of 0, so the initial frequency is 600 hertz, that's given in the problem right here. We know the velocity of the source, which is 90 kilometers, which is given right here. So it's 90 kilometers per hour, which if you work out the math turns into 25 meters per second. And then the velocity of sound, we're assuming that this is room temperature, so it's 343 meters per second. So we have all of our speeds in meters per second. We have our frequency in hertz. So we're starting off on a good foot. Our units are going to get us where we need to be. We also know that this is the Doppler effect. So the Doppler effect is what happens when there's a moving source of a wave. So in this case, it's a sound wave. So the opera singer is moving in this direction. So she's moving towards person A. So as you can see, the sound waves are getting compressed. So when person A hears the sound wave, it sounds like they're at a higher frequency than they actually are. So it's going to sound like the opera singer is singing a higher pitch than she actually is. And then she is moving away from person B. So the sound waves are stretched out, and it's going to sound like she's singing a lower frequency than she actually is. So if you think about if you've ever been around an ambulance, and the ambulance is coming towards you, and it sounds like it's getting higher and higher and higher, and then the ambulance moves away from you, and it sounds like it's getting lower and lower and lower, that is the Doppler effect right there. So that's what we're working with. So from the Doppler effect, we know that the equations that we're going to use are these two right here. So F plus is going to be the frequency that person A hears. So that's the initial frequency divided by 1 minus the velocity of the source over the velocity of sound. And then F minus is going to be the frequency that person B hears. So that's the initial frequency divided by 1 plus the velocity of the source over the velocity of sound. And then pretty much what we're going to solve for is F plus and F minus. So those are our two unknowns, and these are all of our knowns. So here is part A. So here's our equation, which I've just copied from here. So now we're going to fill in some numbers. So let's fill it in. So we know the initial frequency is 600 hertz, and hertz is 1/second. So we're going to make those units that. And then we're going to do 1 minus, and then the velocity of the source is 25 meters per second. The reason I put the frequency in seconds is because eventually these seconds will cancel out. So we have the velocity of the source, which is 25 meters per second, and the velocity of sound is 343 meters per second. Although I guess this doesn't actually matter. These meters per seconds are going to cancel out. Nice. Cool. And then that is going to turn into 650 hertz. So we didn't actually need to change this. But in some problems you do want to change this into 1/seconds just because things will cancel nicely. So 650 hertz. Is that a number that makes sense? Well, we expect that person A is going to hear a frequency that is a little bit higher than the actual frequency. So the actual frequency is 600 hertz. We're expecting a frequency that's a little bit higher, and 650 hertz makes sense for that. Cool. So basically we're going to do the exact same thing down here. So we're going to say 600 hertz, and then we're going to do 1 plus, and then 25 meters per second over 343 meters per second. The meters per second cancels, and this will turn into 560 hertz. So for this number, we expect person B to be hearing a slightly lower frequency than the actual frequency the opera singer is singing. So we're expecting something slightly lower than 600 hertz, and we're getting 560 hertz, which is a number that also makes sense. We would be concerned if we got a negative number. We'd be concerned if we got a number that was way, way far away from 600 hertz. But the numbers that we're getting right now are making sense. So we're happy with those. So those are our F plus and our F minus for person A and person B respectively. Thank you so much for watching my pencast. I hope you enjoyed it, and good luck with the problems.